and welcome back to our channel Astrover Challenge. In this video, we'll be talking about design goals. Before one starts working on a project, it is necessary to define a problem statement. Once that is done, you should start considering design goals. Design goals are a list of objectives or outcomes one sets to achieve at the end of the project. It also acts as boundaries, limits, and constraints within which one has to operate.
The following are the design goals we have chosen for our Astrover project, and they are lightweight, rigid, easy to manufacture, locally available, easy to assemble, ergonomically designed, economically viable, and it also must be safe and rules compliant.
It is not necessary that your design goals should be same as ours. For some teams who are really tight on budget may use heavier materials like steel rather than aluminium, whereas some teams having a generous budget may use materials like carbon fiber and titanium.
It is recommended to put together at least 3 design goals to take you through the design phase.
Personally, I feel design is all about compromise. Before you start designing and manufacturing any component, you must weigh all the available options around you. Some teams may use lighter and expensive material to reduce the weight as much as possible, whereas some teams may use cheaper material on the expense of weight. Some teams may have all the available machines in and around their institution, whereas some teams may have to reach out far to get things done. But at the end of the day, the purpose is to build a rover which will traverse through the course without breaking down. Your design goals must work cohesively towards this purpose. Now that we have listed our design goals, we will go ahead to explain why we chose this for our project. According to Newton's second law of motion, the rate of change of momentum is directly proportional to the force applied. That is, force is equals to mass times acceleration. Assume a case where there are two rovers A and B, where A has more weight than rover B. Also assume the drivers of these two rovers are able to pedal at the same speed for the same amount of time and generating same amount of force. Since rover A has greater mass, it will have lesser acceleration, meaning it will take more time to complete the course. Now, to make acceleration of both rover A and rover B equal, the drivers of rover A will now have to pedal at a greater speed and have to spend more energy. This may, however, lead to increased fatigue within the drivers and may eventually slow them down in the later stage of the course.
Since the rover has to traverse on a rugged surface such as boulders and craters, it is necessary that our design should withstand the unpredictable forces. Factor of safety should also be considered, so under any circumstances, our vehicle should not fail.
Whenever designing any component of the vehicle, the important question you have to ask yourself is, how am I going to manufacture it? If the manufacturing process is too complex, you will limit your build option and it will also increase your manufacturing cost. What tools would you use to manufacture the component? Lathe machining, CNC machining, or laser cutting? For our design, we would be considering manufacturing processes before finalizing the vehicle component and design.
Because our timeline to design and build is very short, locally available component is an important consideration. Not only does this shorten the procurement time, but we will be able to source various components to common vendor, which will reduce the cost.
During the assembly stage of the vehicle, the sub-assemblies must be easily accessible for maintenance and replacement. For example, if you want to work on the brakes, say replacing the worn out pads or oiling them, you must be easily able to do that without removing the chain or taking out an entire assembly. Similarly, removing the entire suspension assembly or transmission assembly just to replace a wheel is not a good design. Ergonomic design is the science of refining the design of products to optimize them for human use. It is necessary for us that drivers have direct access to brakes, steering, seats and pedals. If the pedals are too far, it will reduce the power and also reduce efficiency. It will also cause them inconvenience, which will eventually tire them out. Similar problems will arise if the pedals are too close. If the brakes are not designed considering the maximum effort the driver can apply, the brakes will not function properly and driver will have to apply more force to stop the vehicle. We recommend to have pedals and seat assemblies which can be adjusted to accommodate all drivers from 5th percentile female to 95th percentile male.
We are on the tight budget to build this vehicle and we know most of you are on the same. Hence it is important to consider the whole life cycle of design, manufacturing and testing phase to ensure it is at an affordable budget. It goes without saying that the final vehicle should satisfy all the rules mentioned in the rule book. Every rules are equally important and cannot be overlooked. Safety is one of the most neglected factor in design but of utmost importance. The vehicle should be safe for both drivers and crew members. The final parts should have no sharp edges and should be designed according to good engineering practices. The design process is iterative. The first time onwards, it is possible to not achieve the desired final design. Having the design goals will help us to reduce the number of iterations. If you have any concern, do comment below or write us at astroverchallenge@gmail.com.